just to review this, when you have shapes like a cone or like a pyramid, like this, that has a slant, right? You need to make sure you differentiate between the slant height or the actual height going straight down the center. I think most of you remember that. That is not the main reason I wanted you to go to this slide. The main reason is right here. Sometimes you have to use the Pythagorean theorem to figure out either the slant or the height, okay guys? And this is, the green part is where the problem is usually found. So some students think sometimes the question gives you this part right here, and students take that one and divide it by 2 again. So if you think about A, what is A in this scenario? A is like the whole length right here, right? So if the question gives you the base, like the length of the base like this, yes, you need to divide it by 2. Right? Then you do. But if the question, like if in the diagram it were to do one of these and have the 45 in there, okay guys, you don't divide by 2 again, okay, if this is 45. So you got to use the formulas very carefully. Don't just look at your study sheet, divide it by 2 every time, okay? That is just in general if that is the case, right? So if you need to give yourselves a little note next to this formula, right, just make a little bubble saying only divide by 2 if it's the entire length of the base or something like that. Just saying, okay? Because that does happen. That's why I'm pausing a little bit there. So continue, let's move on. And then I'm going to ask you if there are any questions. I think so far so good. I'm just going to give this another look here. So make sure you have this formula done correctly, especially the cubing versus the squaring, okay? A lot of students go 4 pi r squared divided by 3 for the volume because you're so used to seeing a square, okay? So you got to make sure you go cube there. So that's something that happens all the time. So I'm warning you already. And when you're dealing with a hemisphere, if you just want this part right here is 2 pi r, if you want the base as well, okay, like if this is a hemisphere and you have a little base as well, then you want to add another pi r squared for this base here to have 3 pi r squared. So you got to be very careful, when do I use which one? The question will usually be specific, right? It will say include the base for your calculation of the surface area, usually. But sometimes it's just context should tell you that. Like, what is the specific context, right? Are we making a chair that has, you know, a hemisphere on top of it and it needs to be covered in fabric? Would you cover the base in fabric because that's the part that nobody sees? Most likely not, right? But I will try to be specific and say the base does not need to be covered in fabric, and then you know it's just a 2 pi r squared, not the 3 pi r squared, okay? I think we're good there. The volume of a hemisphere is right here. I don't know if that was on the video because sometimes I add stuff to my notes later on, so make sure you know the volume of a hemisphere. All right, we're good there. Any questions about any of the formulas before I continue? Don't be shy. Come and see me, okay, if you need help. Come in earlier if it's on a first period. That is fine. I would like you to go, we're going to continue with the backwards. Maybe some of you got so excited with my videos that you already did this part. I doubt it. I doubt it. You were like, I'm done. I did the bare minimum. That's all I need to do. And I don't blame you for it. We're going to go to page 10. Okay? Where are you? do some backwards here. So I'll do a couple and then I'll ask you to practice a few today by yourselves. So backwards means you have to do some algebra to figure out one of the missing dimensions. So they'll give you the volume, they'll give you the surface area. You just have to figure out like a radius or a height or something like that. Can you see that? Yeah. Okay. So questions that provide surface area, lateral surface area, or volume will require you to show algebraic steps to determining a missing dimension. You should provide all the details required, all the steps. So let's do the first one here. We'll start nice and easy. The volume of a box has 470 cubic millimeters. The length is 12. The height is 9. Everything is in millimeters, so that's good. No conversions needed. Determine the width of the box. Okay, so the way I would like you to start that is just start with a formula of volume: length times width times height. Okay, and we substitute that in. The 470 is my volume. The length is 12. The height is, the width is what they want, so the height is 9, like that. And I always like to do any computations that can be done on one side. I'll do them before I move stuff around. So we go 470, and then 12 times 9, right? You grab, if it's too early for you to do mental math, right? You just go 12 times 9. It's probably good practice to use this. That's 108 W, right? So the 9 and the 12 can be multiplied. You get that. And then divide everything by 108. Because we want to isolate the variable. That's our ultimate goal, right? So we cancel that out. Some teachers would say, they don't cancel. It turns into 1. Yes, you are right. Okay? You are right. And then you divide and you get 4 point, and now this is the final answer here. It's not like we're going to use this for something else. They ask us for this, so we round to 2 decimals, and our final answer is going to be in millimeters. Okay? So there you have it. I just want to have a little aside. I think sometimes this method will also come in handy, where you still substitute everything. Substitute in everything like that. And some teachers or textbooks or maybe even YouTube videos will show, let's divide both sides by 12. So they go, hey, divide both sides by 12. Because we cancel out this here. That's the ultimate goal. And also divide both sides by 9. Okay, so you cancel out that. If you do this, you just have to be very careful how you enter this into your calculator, okay? Like, for example, you cannot go like this. Right? That's going to give you the wrong answer. It's going to give you 352.5. So if you want to enter all of this at once, you go 470 divided by, you put this in brackets, right? 12 times 9 in brackets like this. And then you get the same answer as we had before. Because if you go 470 divided by 12 times 9, it thinks that the 9 is up here multiplying. Okay? It thinks that this is up here, so that's not the case. Right? So keep that in mind. Let's try another one. I need to figure out my camera here. It's acting up a little bit, it seems. Eh? The volume of a cone is 26 cubic yards. It has a height of 6.5 yards. Determine the radius. Okay. So we gotta go with the volume of a cone. Because we're going to be mixing up shapes, I'll start getting you used to saying, what are we doing here? This is volume of a cone. And what is the volume of a cone? Do you have it on your study sheet? Did I tell you to add these formulas to your study sheet? I didn't tell you that. Probably a good idea over the weekend to nicely, neatly have those formulas that we went over, pages 3 to 9, or 6 to 9, on there. So what's the volume? It's pi r squared times height divided by 3. That's how I give the formula. I know some teachers have the 1/3 in front, but I just keep it like that. It's the same thing. Okay. So volume of a cone is 26 cubic yards. Then we go pi r squared, and the height we're given, and it's in yards. Okay, that's important, guys. Units on the exam. Every once in a while they throw in the curveball, and they give you something in meters, and it's a cubic yards, meters. Convert, right? Just convert. 6.5. And then don't forget about the third. A lot of students forget about that divided by 3 at this point. So don't forget about that. I'm going to use a pen for showing the opposite operations that we're going to perform here. So I want to get rid of the denominator first. Ideally, we want r on its own. That's our ultimate goal. So we're going to go times 3, the whole thing. We're going to multiply this whole side by 3, and we're going to do the same thing to the other side. You do the same thing to both sides. That's really what it's all about, okay? We cancel out the 3's. Over on the other side, 3 times 26 is 78. And on this side, you're left with, because pi isn't a whole number, I'm going to leave it as is. And I'm going to leave r squared in the middle, like this, and 6.5. So basically, we just got rid of the 3, okay?
Carmen Smith to the office, please. Carmen Smith to the office.
And now I'm going to divide both sides by, I'm going to divide it by pi and by 6.5. And these are multiplying. Just like they're multiplying on top here, technically, pi and 6.5 are also multiplying it in the denominator. 6.5, like that. And now you get to cancel. So cancel 6.5, 6.5, cancel the pi's. I'm running out of room here, so I'm just going to continue on this side. Okay, this is where it doesn't really matter how you're going to do this. Do you want to plug this into your calculator? Sure. And get a decimal? Absolutely. I'm going to keep it like that because our calculator can do anything we want it to do, really. So I'm going to keep it like that. And we're left with r squared on that side. What do we need to do now? Square root, both sides. And now you're left with r, because the square, right, cancels the square root. And here's where you want to use brackets, okay? But I'll show you what I prefer to do in this circumstance. Maybe I even show it in the work because there's nothing wrong with it. I'm going to just focus first on figuring out what's in the root. So I'm going to go 78 divided by bracket. You go second hat for pi times 6.5. And then you close the bracket. So I'm just plugging in this part right here. Hit enter. You get 3.8197 something. So my work here is going to show that I've got that in there. And now I'm going to take the square root. So I really don't like, I'm puzzled sometimes why this calculator just doesn't have a square root button, right? But anyways, it's one of the pain here. So second, and then if you look at x2, my finger is right on it, you call the square root, okay? And then you just go arrow up, highlight the number that we just calculated, hit enter to paste it into the root, hit enter one more time, There we go, it's 1.95. Mr. Erickson, would I have gotten any deductions if I went from this step right here to this? No, you would not lose any marks because you're showing us that a square root needs to be taken. Yeah, you just go straight to it, and that's just fine. Okay. I would strongly discourage you from entering this whole thing at once, though. It can be done, but it's if you make a mistake, if you miss a bracket, whatnot, you can get it wrong. Okay. All right. I'm going to ask you to try. Let's go with 3 and 4 for now. Questions 3 and 4. You start with the formula. You can work with your neighbor if you need to. Start with the formula. Isolate the variable that I'm asking you for. Go find the formulas, of course. Those of you that are new or forgot to do a cube root for question 4, you go math. Press the math button. And there's cube root right there. Math 4, okay? Part. So if you want to just follow along and make sure you got it right, appreciate your hard work. So you got to make sure you read this correctly. Lateral surface area of a cylinder. The lateral surface area of a cylinder is 2 pi RH, right? Normally it's 2 pi r squared plus 2 pi RH. We're just focusing on the lateral surface area. A lot of you are drawing them. You know what? It's really good. It's a really good idea to kind of see like what do I have here? What shape am I talking about? Okay. And so the 870 goes in here. Everything is in inches, so I don't need to do any further, conversions or anything like that. 2 pi. The radius is given. If they had given us diameter, guys, what would we have done? Just divide it by 2 to get your radius, okay? So there's various scenarios you're going to encounter, and h is right there, okay? So if you want to do it this way, there's nothing wrong with dividing everything by 2 pi and 19.5, okay? But some of us will want to do this perhaps, 2 times pi, oops, that's 1, 2 times pi times 19.5, let's say. Okay? You did all the math and you figured out that goes 122.52 something h. Don't erase if you did it differently, okay? And then you just say, well, that's in front of h. I need to just divide both sides by whatever that is. And the reason why we can do that is because we have calculators that allow us to copy and paste, right? So we're just going to go 870 divided by, I go up, highlight, right? Bring it down, and divide. Hit enter. So you get the same thing as most of you were getting, which is 7.1. So height is 7.1 or 7.10 inches. Both are correct. Be comfortable with having the variable on the right side. For some of you, that's the wrong side. It has to be on the left. It's fine, okay? It can be on either side. Let's do the volume on the next question. And then I do think 5 is worth doing as well. The volume of a sphere is that many cubic feet. What's the radius? By the way, a sphere, the only variable ever is radius, okay? For a sphere. What's the radius? So let's figure that out. The volume would be 4 pi r cubed divided by 3. Okay, so it's going to get a little messy. So 350 is 4 pi r cubed divided by 3. The first step here is to multiply both sides by 3. Cancel that out. 3 times 350 is 1,050. You're left with 4 pi r cubed. In this instance, it's probably a good idea to divide both sides by 4 pi. You're left with r cubed, don't forget that, and then all of this. Maybe, for some of you, it's going to be better to just go, well, let's figure out this part as a number. 1,050 divided by, use brackets when there's multiplication in the denominator, okay? Divided by 4 times pi, and you get 83.55 something. We use all decimals. That's the indication there. And then last but not least, take the cube root. Cube root of both sides. So with this calculator, it's math, option 4, copy paste, and it's 4.37. Okay. So radius is 4.37 feet. Could you figure out the surface area of the sphere now? Right, 4 pi r squared, and then right. So sometimes you go from the volume to the surface area and so forth. If you're a little overwhelmed, don't worry. It's just day 2 of this course, and we are going over some review stuff. But down the road, you're probably gonna be all right. Okay, this one is a little different. This one has some adding and subtracting to it. Okay, the surface area of a square pyramid, okay, is 42,000 squared yards. The length of its slant, calculate the length of the slant height if the base is 100. So some of you like a little diagram, right? So the way I do it is like that, and it kind of just, so we know that this is 100, and we want to find out this part right here. This is the slant right there. So not the height, but the slant height. That's what we're trying to find. So the surface area of a pyramid would be, what did I give you again? Is it a squared? A is the, not b, right? I use a. Okay, I just don't want to mix it up. It's really the same concept. A squared, that's the base, plus 2 times a times s. So you multiply 2 times the length of the base times the slant. Okay. If you watch the video, you probably know why it reduced to 2as, because there's really 4 triangles, right? And when you simplify that, you end up with just this. Okay. We know that the surface area is 42,000. A is 10, so we're going to go 10 squared plus 2 times 10 times s. Looks like a 5. That's too bad, right? 42,000. 10 squared is 10,000. 2 times 10 is, now I know another mistake that I saw there. It comes to mind. 200, right? You had 200? Okay, sorry. I didn't see that. I need glasses. 20s, right? So you clean it up like that. Now what? There's no dividing yet, okay? It would make it messy. Yeah. I made a mistake. It's 100. It's 100. Yeah, sorry guys. I told you Mondays and Fridays you got to watch twice. My bad, my bad. I forgot that the base is 100. It's not 10. Okay. Any other mistakes right now? We're doing good? Okay. So don't divide. Sure, you could divide by 200, but it would make it, in this case, it would probably be all right. But I would say hold it, right? Hold whatever's next to the variable, hold it, get rid of everything that's around it. So I'm going to subtract 10,000 from this side, and I'm also going to subtract 10,000 from the other side. Okay? Don't add a number with a variable. Okay, you can't do that. 10 plus x stays 10 plus x. You can't go 10x, right? You can't do that. So there, and this ends up with 32,000, and we end up with 200s, okay? So here we can divide now. Okay. And what do we get here? S is You can cancel the zeros, right? So it's 160. 160 yards. Okay. Okay, so I want to remind you of the definition of volume, okay? I will highlight this on the 6th question there. I'm gonna use a different page for that one, because this will come in very handy. So I'll make this a challenge for now, okay, this question. So go to page 12. The last time you did this was probably in intro, right? You did a lot of surface area and volume in the intro course. Maybe you did some in grade 11, but you should have done surface area and volume in the intro course at least, I should say that. So volume, okay, volume of irregular prisms is, okay, this is on page 12, volume is usually you take the area of the base. So let's say you're like, what is the base? A circle. For a cylinder, it's a circle, right? You take that area, you figure out what that is, and then you multiply it by the height of prism. That is always the definition of volume. And I don't know if your teachers told you that in the earlier years. They should have, right? So, for example, a cylinder, right? If you had a cylinder, I'm not artistic, so don't judge, okay? If the area of this base, right? So let's say the area would be 10. Right here. The area of this surface is 10. It would be squared units, correct? And you know that the height of this entire prism is 8. And I ask you, hey, what's the volume of this? What would you say? What would you do? What would you think of after I just talked about this? 10 times 8, right? 80 units squared, okay? Oh, cube. Oops. Cube. And, sorry. Let's do a funnier example, maybe. We're ways away from Valentine's Day, but for me, it's Valentine's Day every day, right? When I go home. If I had a prism that looked like a heart, okay? This is gonna look messy. Just try your best, okay? Okay? And if I told you that the area of that heart is 20, right? The area is 20 and the box is like 10 high that way. What would the volume be? 20 times 10. 20 times 10. Is that the answer? Sort of. 200 units cubed. Okay? So if the province ever gives you like a prism that you have never seen before, but you know the area of the base and the height, you can find out the volume. What is volume really? It's the amount of space that thing takes up, correct? So if you think of the base, the circle here, and you were to stack it, those slices of circles on top of each other, you would find out how much space is occupied. So that's why we multiply by the height, okay? So that's the definition of volume. I would like you to not take up this much space on your cheat sheet, but to have at least this. Sorry, I need to figure out how to work this yet. This is very important. This only works for regular prisms. What does that mean? that the base can be stacked and you have the same shape all throughout, right? Like a pyramid is not a regular prism because it's slanted, right? You have a pyramid, a square pyramid has a square, but you can't stack the squares, right? Then it would not be a pyramid anymore. So that's what a regular prism is. To be continued. Okay. I'm going to stop this lesson here.